So today we're going to be talking about irrational numbers in the denominator. So first, what are irrational numbers? An irrational number is a number that cannot be expressed as a simple fraction. Some examples include square roots of non-perfect squares, pi, and e. And what I mean by non-perfect squares are things like the square root of 2, the square root of 3, and like I discussed, pi and e are also considered irrational numbers. So, first, when rationalizing the denominator, when an expression has an irrational number in the denominator, we often have to rationalize it. We often have to rationalize it to remove the irrational number from the denominator. This involves multiplying by a form of 1 that will eliminate the irrational number. So, for example, if we have 5 over the square root of 3, this square root 3 is an irrational number. And so what we have to do is we have to multiply this by 1. But we can't just multiply it by 1, right? We have to multiply it by a form of 1. So something that would look like is the square root of 3 over the square root of 3. Now the reason we do this is so that this cancels out that square root, and since what we do the denominator, we have to do to the top, we have to multiply 5 by the square root of 3 as well. So then this leads us to our final answer of 5 square root 3 over 3, because again, these square roots, they just cancel out altogether. So that was one of the more simpler terms. However, you may be asked to rationalize using what are called conjugates. So for binomial denominators that include square roots, we have to multiply by the conjugate. The conjugate is the reverse sign between terms. And what I mean by this is, like, for example, if we have a plus the square root of b, then the conjugate will actually be a minus the square root of b, right? So what's an example that we can use for this? So let's say that we have 4 over 3 plus the square root of 5. So this whole denominator kind of looks like this right here. So we're going to have to multiply by the conjugate pair. So we'll have to multiply this by 3 plus the square root of 5, because again, we want to multiply by a form of 1 so that it stays the same. And when we do this, we get 4 times 3 minus the square root of 5. Oh, I'm so sorry. This was actually supposed to be minus, because it is the conjugate pair. And then on the numerator, we just have 9 minus 5. Because when you multiply these, it's 9, and then this will cancel out that, right? So going from here, we will have, I'm just going to do the denominator first, so we'll still have the same 3 square root 5 over 4, because 9 minus 5 is 4. And then, since these now cancel out, these 4s will cancel out, you're just left with 3 minus the square root of 5 as your answer. So there may be some special cases that we run into, right? And these special cases are if the denominator is a perfect square. For example, it could be square root 4 or square root of 9. Then we can just simplify it directly, and it would become, this becomes 2 and this becomes 3. And then always make sure that you are simplifying after you're rationalizing, if it's possible. So an example of this would be, let's say we have 6 over square root 16. Well, we know that the square root of 16 just equals 4. So then this is 6 over 4. But since we can actually simplify this after we just rationalized it, then this actually becomes 3 over 2, and that's your final answer. So let's do a few more examples just to really drive the point home. So let's start with just rationalizing with a square root. So let's say that we have, for example, 7 over the square root of 2. So you just want to multiply by that form of 1, which would be square root 2 over 2, because we want to get rid of that square root. And this would lead us to 2 over 7 square root 2. And since you can't simplify any further, that is your final answer. Another example, let's say that we have 5 over the square root of 7, right? And so just like the other one, we want to get rid of this square root 7 at the bottom, so we would multiply by the form 1 square root 7 over square root 7. And this would lead us to get 7 over 5 square root 7. And again, since you can't simplify any further, this is your final answer. So now looking at more of maybe a conjugate pair for examples, let's say that we had 5 over 2 plus the square root of 3. So right here you'll notice that this is what a conjugate reverse would look like, our a plus the square root of b. And so we want to multiply by that reverse conjugate, right? So we would multiply by 2 minus square root 3. And again, you want that to be a form of 1. And so you would multiply it out like that. And you would be left with 5 multiplied by 2 square root 3. And on the denominator, you would have 4. And then since the square roots go away, you'd have minus 3, which just equals 1. So you'd be left with 1. Now you can leave the numerator like this, since it is over 1, it's a whole number. Or you can distribute this 5, and you can simplify it more out to 10 minus 5 square root 3. And that would be your full final answer. One more example we'll do is, for example, if we had 8 divided by the square root 6 minus 2. Now, while this doesn't look like our conjugate pair of a plus square root b, it still technically is, since we do have a square root and we're adding or subtracting something to that, right? So we would treat it just as the same as our last problem, but instead we would do the square root of 6 plus 2, and then do that same to the top. And then what we would get here is we would get 6, and then negative 2 times 2 is negative 4, and so it would just equal 2. So in our denominator, we just now have 2, and in our numerator, we have 8 times square root 6 plus 2. Now, since 8 can be divided by 2, it's actually going to leave us with 1 over 4 square root 6 plus 2. And if we just factor in that 4, your final answer will be 4 square root 6 plus 8. So, in conclusion, when you are dealing with irrational numbers in the denominator, what you want to look for is multiplying that denominator and numerator by some form of 1 in order to get rid of that square root. To do this, you might have to, multiply by a square root to get rid of the square root and bring that square root up towards the top, or you might have to find the conjugate pair of it.